Okay, we're going to walk through example 7 here. It's going to be very similar to all the ones we did with I, only now instead of I, we're using K. So we can also use, K as a different variable as I to do our summation substitutions. So let's look at, we have K equals 1 to n of 6K times the quantity K minus 1 all over n cubed. This is just like the previous example where we're going to do substitution and things like that. Only instead of I, we have K. All the rules still hold true. So what we want to do is get the sums in terms of K only and factor out any of the constants and the n's out of the situation. So if we look first step, alright, we're going to factor out the 6 over n cubed. That leaves us with k squared minus k. That's perfect. We write that into two different summations. Alright, and then we're going to go back to 4.2, theorem 4.2, which was on page 2 of the notes at the top there. And where it has I squared, same thing as K squared, so we're going to replace whatever the summation for I squared is and the summation for I. So the summation for I squared is here. It's the n times n plus 1 times 2n plus 1 divided by 6. And the summation substitution for a single k here is n times n plus 1 over 2. And we're still keeping that 6n cubed out in front. Alright, we factored that out. That will get distributed through. The rest, guys, this is just kind of repetition on getting better at algebra. If you're going to notice, most of these are going to just involve doing the same foiling, the same distribution. Really, the main term that's going to adjust is, are we adding them or subtracting them, or and then when we distribute, what's in front through. That's really what's going to be changing everything. So once again, it's still multiplying n plus 1 times 2n plus 1. That gives us the 2n squared plus 3n plus 1 times this n out in front over 6. And on the right hand side of the subtraction sign, we're going to distribute n through, so you're going to get n squared plus n over 2. Okay, and then stepping down here, we're going to distribute the n through, so you're going to end up with 2n cubed plus 3n squared plus n all over 6. Nothing really changed on the right hand side. You can distribute that negative through now if you want to. One thing we have to keep doing with these is find the common denominator. Probably could have chose 6 as a common denominator instead of 12, but just good practice for us. Multiply the left hand side by 2 over 2, the right hand side by 6 over 6, and we would have everything over 12. So when you do that, remember that 2 over 2, that's multiplying by 1, but we're getting a common denominator. Remember that numerator has to distribute to each term in that polynomial. So you have to go 2 times 2, 2 times 3, 2 times 1 here. So you're going to get 4n cubed plus 6n squared plus 2n. And then on the right hand side, okay, we're going to distribute the negative and the 6 to each term. So minus 6n squared minus 6n. Alright, combine like terms, simplify fractions. That 6 that's out in front, we have that 6 over n cubed, that can go into the 12, alright, and put everything over 2. So you guys can kind of go down here through the algebra. I've kind of laid out, the different ways, different forms. Once you get down to, this form here, 4n cubed minus 4n over 2 times 1 over n cubed, you're going to just kind of have to, I would access something like that personally as an example. If we were doing a written test, but since you're doing multiple choice, you're going to have to play with the algebra as far as getting to the right solution on how you do that. So you guys can look through the different steps there. It's really just algebra, nothing overcomplicated for you guys to get through that simplification. The biggest part, I believe, is, let's scroll back up here and take a look, is for you to understand how to factor out the constant and the n at the beginning, and then get everything in terms of k or I or whatever variable that we're going to use, so that we can apply theorem 4.2 and do the substitution. So that's the biggest thing here, is being able to see how to go from that initial summation and write it to a summation where we can work with and do our substitution and get it down so it's completely in terms of n.